everybody. Today, this morning, or whatever day it is for you, we're doing squares. So in this video, that's what I meant to say, we're doing squares. Now, squares are special. Squares have a lot of rules. Squares are actually parallelograms. They're also rectangles, and they're also rhombi. So I'm going to go through this. I'm going to skip to my document camera. So square is a parallelogram, so it uses all of the parallelogram rules. It uses all of the rectangle rules and all of the rhombus rules. The square doesn't really have its own set of rules. It basically is a combination of everything. So things that work on a square. Okay, things that work on a square. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. Chester. Okay. Diagonals separate the parallelogram into two congruent triangles. That's just the parallelogram part, but we also have rectangles. Okay. Rectangles have special rules, so rectangles also parallelogram rules. But the special things about rectangles is the diagonals are congruent. So you have equal diagonals, and all four angles are right angles. Obviously, that's like that on a square. And then rhombus, the special things about rhombus, so rhombus is not a rectangle, but a rhombus is a parallelogram. And the special things that a rhombus has is the diagonals are perpendicular, all sides are congruent, and the diagonals bisect opposite angles. So those are all of the rules that apply for squares. So we have to kind of go by everything. A square is basically a parallelogram that is also a rectangle and a rhombus at the same time. So this example now. Here we have a square. It says QR is 3. So let me get a color here. Just a second. Sorry, when my color was out of lead and I forgot to replace it before the video started. So I'm replacing it now. Okay. QR is 3. There we go. QR is 3. Again, bear with me on the lead. If you've already watched the rhombus video, then you know that my lead just keeps breaking over and over again. So I'm going through a ton of lead. I wish I had all my refills from the classroom. Okay, so QR is 3. We need to find SU, SA, measure of angle QRU, measure of angle QAS, the perimeter of the square, and the area of the square. Okay, you do have some problems in some random assignments that ask for perimeter and area, so I just thought I'd go over it real quick just to remind you, because perimeter and area is something that you did in not elementary school. Well, you did it in elementary school, but for these shapes you did it in junior high, so just kind of remind you of those rules. So SU, where's SU? Oh, SU. SU is this diagonal here. SU, we have information about diagonals. We know that the diagonals bisect each other, so that means we have equal parts. So if QR is 3, that means RA is 3 as well. We also know from a rhombus that the diagonals are perpendicular. That means the diagonals make 90-degree angles. So we'll have a 90-degree angle here. All 4 angles here are 90 degrees. All 4. And then on a rectangle, it says the diagonals are congruent. That means the diagonals are equal. So if this diagonal is 3 and 3, then this diagonal is 3 and 3 as well. So this is 3. Sorry about my hand, they're covering it up. Try to write so that you can see as I'm writing. So that means SU is 3 and 3, which makes 6. Okay, so that gives us SU. Now we need to find SA. So if we look, SA is on a triangle. We're going to have to use some triangle rules for this, because we don't know what the outside side is. We know it's a square. We know all 4 sides are equal, but we don't know what the side length is. Okay, so we're going to look, I kind of colored the outline of the triangle we're going to look at. The angle inside, where the letter R is, that's 90 degrees, because the diagonals are perpendicular. So rhombus rules. So if we look at that triangle, we have a 90-degree angle there. That's R. That's S. That's A. We know that this is 3 and this is 3. Okay? And we need to find this side. So we do the Pythagorean theorem, just like you did in the rhombus video. Pythagorean theorem, a squared plus b squared equals c squared. And if you watched the rhombus video already, you know that c squared is the most important part. C squared is the hypotenuse. So if you find the hypotenuse, remember the hypotenuse is away from the right angle. The right angle points to the hypotenuse, so our hypotenuse is out here. And for the other 2 sides, it doesn't matter which is x and which is a and which is b. So, well, they're the same thing anyway. 3 squared plus 3 squared equals x squared. Just a second. I was looking at my example. Okay. 3 squared is 9 plus 9 equals x squared. So we do our squareds that we can. We can't do x squared. So 9 plus 9 is 18. And then to get what x equals, we do the square roots on both sides. The square root gets rid of the square. We're only worried about the positive square root. So when you get positive, negative, you don't need to worry about that positive, negative sign when we square root both sides, because we're just worried about positive lengths. Lengths can only be positive. Now, 18, square root of 18, is 6 times 3. 6 is 2 times 3. We have a pair of 3's that break out. We have this 2 that cannot break out. So radical 2 equals x. So now we know that x is 3 radical 2. If the problem asks for the nearest tenth or the nearest hundredth, then you just put it in your calculator. So if it asks for the nearest tenth or 100th, my calculator, I would just do that, square root of 18 equals, and then I would have my nearest tenth. So you just have to adapt for whatever kind of calculator you have. That's how I do it. So now I know SA is 3 radical 2. Okay, I'll put that here. 3 radical 2. Okay. Measure of angle QRU. QRU. QRU is this angle here inside, and since the diagonals are perpendicular, we already know that's 90 degrees, so that's an easy one. QAS. This is actually from your rhombus rules. If you watched the rhombus video already, which I hope you did. Diagonals bisect opposite angles. Okay? So, if this whole angle is 90 degrees, the diagonal bisects it, which means 2 equal angles. So, for angle QAS, you take your 90 degrees and you divide it by 2 because it's half of the 90 degree angle, which is 45 degrees. Okay. So angle QAS is easy. The perimeter is add up all the sides. That means the outside sides. Now, since we know that SA equals 3 radical 2, then we know this side is 3 radical 2. And we know this side is 3 radical 2, because it is a square. All the sides are equal. Okay. So then we just add that up 4 times, or we could times by 4. So we have 4 times 3 radical 2. And since 4 is a whole number and 3 is a whole number, those are the only things you can multiply. So we get 12 radical 2. Okay, so 12 radical 2 is our perimeter. We don't multiply the radical 2 by 4. And then the area. You've heard area before as length times width. Okay, on a rectangle, length times width. So length is 3 radical 2 times the width is 3 radical 2. You can multiply the whole numbers together. 3 times 3 is 9. And then radical 2 times radical 2 is the radical 4. Well, radical 4, square root of 4 is 2. So we get 9 times the 2 that breaks out, which is 18. So our area will be 18 in this case. So there is our square lesson. Okay. We won't be checking notebooks, but it will help you when you take the test if you have the rules written down for each shape. So have a good day.